Thank you very much, Lorenzo. So I'm Andrei. I'm technical leader of Cloud Communication Business Division at Alcatel-Lucent Enterprise, and we are glad to share our experience with Janus. So we are working on a Rainbow platform. Rainbow platform is the platform to connect in terms of unified communication and in terms of communication platform, UCaaS and CPaaS, persons, devices, and bots. Just to give you a small context of the solution. So we have started to play with WebRTC in 2020, started by peer-to-peer audio and video call. So we have founded a Rainbow solution in 2014, also starting from chat, basic chat capabilities as well as audio and video calls. So our main goal was to connect PBX world with a rich telephony asset to unified communication platform. And by small pieces, we have added several WebRTC capabilities. So let's do this basic. So the basic one is audio and video conferences. So we have also the capability to have a screen sharing, also to several operations like mute, etc., and the possibility to invite the guest following the external link. So in terms of architecture, so we have based our system on microservices approach. So we have external layer that is implemented by REST APIs and events that we transform into WebSocket, secure WebSocket messages. So we have microservices to enrich our API solution, and we transfer all the events internally by extensible message bus. So for the Janus Gateway, we have implemented Janus Gateway microservice that communicates with Janus by JSON protocol. And for the first solution, we have used two plugins to implement audio and video conference. So the first one, it was Audio Bridge for to have mixing audio capacities. And from Video Bridge, we have taken only the part of video stream. So audio is mixed and shared with every participant in the conference. And in terms of video, we use a subscription mechanism, and every person can subscribe to interesting videos of other persons and use it. So it was for a small technical part for orchestration part, because it's a cloud solution, so it's several data centers. We have here the possibility to update, and it should be as seamless as possible for our end users. So we have implemented the component, call it a media orchestrator. So before we schedule a conference, so we ask media orchestrator about available instance. Available instance, it's a Janus instance that has a less of users, active users and active conference. And this is the instance that is not in stale mode, it's in the active mode. Stale mode, it means that this Janus instance doesn't accept any new requests to future conferences, and once the last conference is finished, so we can reboot Janus server with a new instance, and for end users it's completely seamless. So going further, so in 2017 we have started to implement PSTN bridge because it's okay to use sync audio and video capabilities using Rainbow clients or using just a browser, but it's also necessary for several persons or for several clients to have a PSTN bridge. So to have a kind of PSTN public numbers available with the code, and after that to join WebRTC conference for using their standard phones. So we have enriched later this capability to have screen sharing only mode, to have only screen sharing on, for example, browser client, and we can have audio on standard phone in order to use client existing audio system. So so here we use the first plugin called SIP plugin in order to be unregistered to a cloud PBX. For a cloud PBX, we use SIP voice-based solution with several trunk connected to several European operators, and to have external IVR in order to implement PSTN bridge for this solution. So it was quite interesting solution, but we would like it to have more challenges, more technical challenges, and increase the complexity. So the first one, it was recording, because it's okay for the persons that can participate to video meeting, but sometimes some persons can't participate, so it's better to have a kind of video that they can play later in order to be to be informed about the conference status. So for doing this, we haven't used it recording plugin. We have used existing Janus recording capabilities. So once conference ends, so there's a kind of event that we put in a sort of working queue, and where several workers to transcode existing files, because we can have audio with pause and resume. So it will be several audio flows. We can have multiple screen sharing by different persons during the conference. It will be also the different video files. So we need to assemble it together, to put it together, and to have one format acceptable for to play on mobile and or also on web devices. So once we transcode the file, we put it in our internal file storage, and we notify current client by internal event and also by email that recording is done. In this case, client could connect, could use the connection via our Rainbow platform, or just a link in the email to download the file and to have conference video. Also, just in the beginning of 2020, we have started to think about multiply much more video flows that we can have, because for the routing it's okay to have several video flows, but once we start to have a kind of grid, video grid, sometimes we are limited by decoding, encoding capabilities on sync web browser or even on a mobile device. So to avoid this limitation, we have implemented video grid with the video mixing part. So in terms of architecture, so it's the same one. we continue to use audio bridge to mix audio flows, and we have an external component called Video Compositor that is based on GStreamer. That is just a simple subscriber in a video room. This component receives all the video flows from a current room, and it mixes together the video flow, and it puts it back to the Janus, and Janus do the streaming to all of participants. So this is also one from other extensions. So we have implemented EcoTest. So it's simply the usage of Janus plugin for EcoTests, but the devil here is on the details, because we need to analyze the full subset of WebRTC stats in order to give something interesting to each client. It's not only about most capabilities for audio flow, but it could be something, also some recommendations about video flow that current can take into account, and after that to maybe to change something in terms of network, maybe to stop several other applications on his computer, etc., etc. So once we have done it, so it was an interesting solution that worked quite well. But in parallel, we have started another one. So for audio video conferencing, something that is immediate. It's something that happens in real time, so we can schedule it quite time before, but for audio and video, so all the persons are connected, and almost all the persons have the same right. So we have started to implement another mechanism called webinar. So for webinar, it's a scheduling part. So owner of webinar can schedule webinar about several weeks before. So it helps us also on orchestration level to put the webinar at the time on the right instance, because it should be on the Janus instance that is not very charged in terms of workload, and it should be the nearest instance for a person that has started the webinar. And also there is another thing for the webinar. It's a kind of waiting room, so persons arrive and they start to chat between them. And in parallel, we can put a kind of external video just to play before, to announce the webinar subject, etc., etc. And we have the notion of stage. Where it's up to 10 participants on the stage that could share their video and also the screen sharing. And we have listeners. Listener can just chat with the others, but he can't be promoted as organizer, and as speaker he can only participate and listen webinar. And after that we have implemented also a pooling mechanism, so we can ask some questions, and after that to have some reactions from the webinar community. So the first version of webinar architecture, it was quite similar to our audio and video conference, except that we have used only video bridge. So it was no more audio bridge in the loop, it was only video bridge. To doing it, we have started with several hundred of participants, and we have faced it with some technical issues going on the single mentions with 500 persons. And in this case, we have worked quite long and implemented the final webinar version, scalable one, that is represented one Janus that is in streaming mode and several other Janus that are in listening mode, and also in terms of packet forwarding, they stream to the clients. And in this case, we have implemented scalability up to 1,000 users. So also here the idea was not to use very powerful machines because it costs. It should be physical machine, but for the second version of webinar, we have used several small virtual machines, and it works very well. So some lesson learned from Janus usage. So it's a robust component to implement audio and video interactions. So here we, during several last year, we haven't had almost any crash on this component. So with quite heavy load on every component instance. So component is also very flexible. So we have implemented a lot of things, not the basic one like audio and video conference, but it could be easily extensible to implement external grid, external recording, external echo test, and a kind of advanced webinar. So this is a component that have a good performance comparing to other solutions from open source world. So it could be maybe better, but in this case, it's necessary to go mostly on kernel level to route the packet. And also this is a very good component to integrate in cloud ecosystem, because there is almost everything, at least for our needs, that we need to have a proper component monitoring and to have a quite advanced system of media orchestrator to schedule better the conference and to avoid to surcharge several components with a lot of traffic. So I think from me this is all. If you have any questions, I'm quite on time.
Thank you, Andrei. This was very, very interesting. So do you have any questions? Any curiosity? Okay. Thank you very much.
Thank you very much.